Hello guys and welcome back. Today we will continue with the Advent of Code 2024. Last video we managed to finish the day 3, so let's continue with the day 4. And without further ado, let's get started. So let's go back to the front page and then check the day 4. So looks like the chief's not here. Next, one of the historians pulls out device that pushes the only button on it. After a brief flash, you recognize the interior of the series monitoring station. As the search for the chief continues, a small elf who lives on the station tugs on your shirt. She would like to know if you could help her with her word search, your puzzle input, okay? She only has to find one word, Xmas. This word search allows words to be horizontal, vertical, diagonal, written backwards, or even overlapping other words. It's a little unusual, though, as you don't merely need to find one instance of Xmas, you need to find all of them. Okay, here are a few ways Xmas might appear with the irrelevant characters be replaced with dots. Okay, so it can be, okay, interesting. Yes, in the sense clear. The actual word search will be full of letters instead of, for example, like this, okay? In this word search, Xmas occurs a total of 18 times. There is the same word search again, but where letters not involved in any Xmas have been replaced with dot. Take a look at the little elf's word search. How many times Xmas appear? Get your puzzle input. Okay. So let's start day 4 part 1. Yes, and then input. Yes. Let's wait. Runtime allocation. Yes. Then we can start. Let's first just print the input. Yeah. Yes. So if we can play with the idea a bit. So I was thinking that if we would first split this in rows. Okay, why didn't, or did I mistype something? So we have 140 rows. Okay. And then, just out of curiosity, we check the first one. So how many items we have in the one. So it's 140 by 140 matrix. Okay. So basically, if we think about it, that we have something like this. And if we would go through by every character, we can then check that, or we should check that if example, we start by checking the location of X, we should check that is there any M characters nearby, and we can see that there is. And then based on that, we can check that does the M have the character A in position that we would need it to be. So example in this case, because the X can be anywhere, M can be anywhere, only kind of requirement is that the X is there next to it. And then it kind of rules out that the A needs to be next to the M, but there is only one location that we allow it to be. And then the same applies for the S. Okay, we can kind of start to split the problem. Basically, we can do recursion here, which is, I think, the one way to at least start solving this. Okay, let's start. So if we define, we can actually remove this section here. Yes. So basically we find char from position. Okay. So what this needs, it needs the input, or not actually the input, but we need to modify it a bit. And then what it needs the character that we are looking for. This is actually type of list. It's a list. I have been writing too much TypeScript lately, so I think this is the or actually it is list if I now recall correctly. Yes, typing list, yes. So then the character will be located. This is basically a string, and then location. And this would be a tuple of integer. And yeah. So then, this is actually optional. Yeah, because in the first case, or actually, yeah, char location. Okay, so this location is for this character, and then we want to have the current position as tuple int. Okay. The row gets a bit long, the row, but I think we can clean it a bit like this. Yes. So we need to check that if char location is none. Then we basically loop. Maybe we need to check the locations around this current position. And so basically the positions to check would be an array of tuples, and it would go current position, maybe we want to actually split current x is the current position 1, and then the current y. Kind of, let's first figure out the initial kind of the best, or like the common scenario where we around our current position we have characters all around. So basically the position would be something like that. We have like current so if we start from the top left, we have our current, or actually we have now too much stuff here. Current x minus 1, and then current y so basically if we think the coordinates so that the 0, 0 point is on the top left, we can say like this. So this is the first coordinate. Then for the next one, we will otherwise be doing the same, but x is the same. And then the last one is x plus 1. And we can actually split this like this, so we can keep it a bit more readable. Then just copy these. Yeah. Plus 1, yes, and then the y in this row is the same, and then plus 1. Okay, so this is the happy path. Then we have this case when we are going kind of out of bounds. So we could do so that I'm wondering, should we kind of check that is the current x between 1 and 139, and actually yes, let's split this a bit, because we know kind of what we will do. So let's do actually like this. So first we just initiate positions array, yes, and then if we can see that current x is below 1, so basically is 0, then we will do position append, and what we will append, because we know that it's in the beginning of the row, we will append everything else than these current x minus 1s, because it would go kind of over the boundaries. So we will append list of these. I think it is now let's see how it behaves. So basically all current, basically these are the positions we want to get rid of, and then was it done like that? I now need to test. So if we have a list of items, and then we have a which equals empty list, and then a dot append t, and then we just print a. Yeah, it's like that, or was it like this? No, maybe this. Oh, yeah, yes, of course. So then it's actually a plus t, I think. Yes, and if there's something here, let's say a. Yes, so it's not append, it's just positions equals positions plus. So yeah, this will be added. I can actually see some issues there already, but let's not yet tackle those. Current x is larger than input, len of input. Yes, so this is the length of the row. And then we need to minus 1 so that we can, or actually, no need. We can just say that it's equals to that. Then we won't add the last part, so we will do positions plus, yes. Let's actually split it like this, just to keep the readability a bit better. So now we know that it's in the last position, so we remove everything that says plus 1. And yeah, and then in the end, if it's else, which that everything. Yes, that's clear. One thing that we need to maybe check is that if, since this is checking the X position, then if we check that current Y is 0, okay, then we need to check that or first of all, we can't use elifs, we need to use ifs, since we need to run both statements. You will see shortly why. Here we can just check, is the current X 0? If it's 0, or actually, let me think a bit. Okay, let's first check if both of those are zeros. Then we know that we actually can add very limited set. So basically, both are 0, so we can't use these ones that are doing some -1 stuff. So basically this row goes completely. Then actually we are good. So from current position, is the start. So kind of actually we can remove even this one since it's the current position. We are not interested in that. So we have 3 directions where we can kind of go. It's the one left, one down, and sorry, one right, one down, and one in the between. Okay, yes, and then if elif, so if current X is 0 and current Y is not 0, or maybe it's clearer to do it like this, then we can basically add these. So we know that we are in the beginning of the row, but the row that we are on is not the first one. So then we have also the upper row available. And here we can also remove the current position. It does not really make sense to have. And then we have the last case where the logic is reversed. So in that case, we have x that is not 0, but y that is 0. And what this basically means is that we are positioned so that we are in the first row, but we are somewhere like between the last and first characters. So for that case, we know that we can't use any of these positions where y is y minus 1, but otherwise we can use or wait a second, did I do an oopsie? Yes, it was correct. So it's like this, and here we can also remove that one. So it's kind of same as this row, but just negative x or minus 1x. And then current y, yes. And then we need to do similar thing for the 1 is 0 and then 1 is maxing the length. Up. Yes. Up. So actually, input, it should go like this, yeah. So then we need to do the same thing, besides the fact that we can't actually we need to do it like this, because or maybe let's get have it slightly simpler. Kind of we know that it's 140 by 140, so we don't need to make any scalable solution here. And then we first handle the case where x is like that, and then we can handle the case where y is that. And here what we need to do is that we know that both are on the upper limit, so it's the bottom right corner. So what we know then is that we need to add only the positions where one or another is subtracted from. So basically all these can go. And then in this case, we know that the x has reached its max value, but y has not, so we are not in the bottom row, but we are end of some row. So we know that in every row or item location where we add to the x, we need to remove. Actually, is there something? X. Am I actually missing some values here? I think I am. Because we have potentially nine directions. Yeah, actually this is the kind of the original row. Yeah. Okay, let's start again. So in this case we know that we are in the bottom right corner. So every value that tries to add neither of these need to go. So basically these will go since neither of these can be added to. Yes. And then in this case, we know that the x is the one that can't be added to. So here x is added here as well, and then there is this current position. We don't need that here as well. Yes. And then in this case, we can add it here. So we know that the y is the one that we can't add to. That's fine. That's fine. Yeah, I think now we are good. So actually, I think now we should have relatively good positions to work with. I'll just comment this out so we have this still available if we need to work on this. And maybe I'll do some calculate locations, and then based on input and that's list, and then the current location position. Yes, and then that will be double int. So basically we can just remove this and hide it under here. Return positions. we need to actually modify this a bit, since we know that or actually, let me think. Yeah, we don't need this here. Yes. We need to just check here that if not char location, then positions calculate locations, and then we need to give this the input and current position. Yes, and then if we can actually position to be char location, and then check if position, yeah, and then actually we can or should make it, or actually, yeah, let's keep it how it was. Positions, we can just initiate to be empty array, and then set positions to be or actually we can just append char location. And then we want to loop through position in positions, and what we want to check is that can we find the character that we are looking for in these positions. So basically, if input position 0, position 1 equals to the char to be located. So basically we found the character. Then we will just say return, and let's return the position, or if we didn't find anything, then return none. And with this, we should be able to locate the characters, because every time we call this find char from position, we know that which position we are currently in, and then when we get the next position, we can then say that in which direction the next character should be from that point. Okay. Then we can or actually, let's maybe split this a bit. So if we run this code block, yes. Tuple is not callable. Okay. Did I miss a comma? Yes, I did. Indeed, miss a comma, and let's check that here is missed comma as well. Yes, this is looking good. Okay. And we can actually start to use this. So for basically with xchar locations, so if we split this a bit, so first we are interested in to get the locations of the beginning of this x word or xmas word. We need to locate the x characters. So if we are then actually we want to maybe do here, since we need to compare the string values, we want, or actually was it lower is not defined. Aha, it was here dot lower. Yes. Yes, cool. So basically now we just go through the char in input. If char dot lower equals x, aha, yeah, because actually this is more interesting. It's not just because it's this is actually, but we want to do the we want to do the manipulation of the input a bit so that we can get this matrix already. So basically we do so that manipulate input is basically this, and then we call split. We should have this, or actually then we have a string. Okay, let's check how this will look like now, just to make sure that we are playing with the, do it like this. Okay. Or char in many, or maybe we can just like skip that and, oh yeah, maybe let's actually call it, yeah, like this. Then if char dot lower equals x, then we want to, or actually this is a row, and we want to maybe actually call enumerate here, and because this is row, and then did we have first the index? I think we maybe did. Then the item. Yes. And then if we do the for char in row, yes. Actually, here we need to use the index row index and then char index. Yes, so basically this is y and this is x. Actually, we can do so. And here we can see that if character is x, we can add x char locations that append x and y. Yes. And then we need to inline this. So now if we print x char locations, we should have a quite nice list. Yes, indeed we have. How many actually we have there? We have 3036 candidates to be word Xmas. So the next is, since we kinda know what we are looking for, or not kinda, we know what we are looking for, we can say that next ones are M, A, and S. And since we know that these locations, xchar locations, they have the x in them, we can loop through the characters for every x char location. So for location in x char locations, so starting points of the word, we can call this find char from position. And for char in char to look, we want to check that or go through these characters, but let's maybe first split the task a bit, or like let's try the function. So basically, let's have a counter, and then if find, like let's find char from position, and this one's the input, but in this case manipulated one. and then it wants the current position, which is location, and then it wants the character that we are looking for. So let's just use M, and then char position. We should check if char position, if not none, then let's add counter plus equals 1, and then let's print the counter. Okay, we have some issue. Is it this? Okay, everything is none. Interesting. Do we have an issue? Do we have an issue in our implementation? Okay, so let's just, since we know this, so basically the first, second, third, fifth, sixth, seventh, eighth, ninth. So ninth. So if we select the ninth position, sorry, not ninth. It's the 1, 2, 3, 4th. Yes. What? Okay, and then location, current position. Type int location. Yeah, of course. We need to do now this. Yeah, sure. Of course. Okay, none. Interesting. Why it's none? So it will go here. The location is 9, 9 and 0. So it will go here because y is 0. And then it checks that, okay, first, if both are, no. If x is Why it does not? Okay, then it goes here. Okay, let's actually do one thing so that we are not shadowing this inputs. And then inputs. Yeah, let's do it like that, and then still none. In the sense, fine. Okay, let's then check here the positions. I'm wondering now, do I have some kind of like logical error here? Positions. Okay, so it has positions. Let's check actually that, because it, okay, now it found that. I think it was some kind of shadowing, yeah, definitely. Must have been. Okay, so we know now that, so we were in this position, so yeah, then the 8 had it. Oh, true. It may have many. It may have many. Since, example, in this case, yeah, it. Or did I give the 0 no, second? Like, what is the 2, 3, 4, 6, 7? I think I gave the wrong position. Though, why there is 0, 0? Okay, yeah, true. And then 1 and 2. Yes, correct. Let's copy this. Starting. So we have these. So yeah, looks correct, 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 correct. I'm just wondering why. Ah, yes, yes, yes. No. I have some logical error now. Most likely in this. Yeah, it won't go to the 10th. Okay, yeah, we are completely missing something here. X is not 0. Start to wonder that are those the culprits? What kind of positions we are getting now? Nothing additional. So basically we are yes, we are missing the kind of the else. So if or am I just kind of what is let's actually have it like this. So I think let's do it again. Let's do it again. So here, if x is 0 and y is 0, we know that we can subtract from them. So anything that tries to subtract needs to go. Yes. But then here, or is this the only one that is wrong? The y is the one that we can't subtract from. And then here, let's double check this one as well. Here the x is something that we can't subtract from. Okay, let's try it now. Why it says 8 and 0? What is this even? What I'm missing here now? So if we get like in so if we do it like this, and then we try to fetch the first row. I think I have mixed somehow the coordinates now. But so if you run this, it says X. Aha. Yes. Of course. Of course, of course, of course. Yes, like this. Now it will work. Maybe I should have made data class or something. Yes. One. Okay, cool. So if we, since now we know how many, oh, there is so many prints. Let's remove that one. Then, yeah, that one. Okay, 73 potential candidates. So then, since we knew that we found something, we can do so that next we need to kind of figure out in how this X and M is kind of how they are kind of located compared to each other. Yeah, so we need to figure out in which direction the character is, and then move kind of towards that. So we could rename this to mchar_pos, and then if it's set, we know that there is m character next to the character x. So next thing we want to check a character. And now it's the first time when we kind of try to utilize this exact position finding, which we implemented already. So if this char location is set, then we are not looking all around, but only from that position. And for that, we need to get the location. So basically, what we are in the sense looking for is that, okay, kind of in short, it's x_pos change and then y_pos change. And what this basically means is that when we got the results from, so basically this mchar pos, we will check the difference between that one and the original location. So basically for x, we will check that what is the change, and then same for the y, but of course from the position 1. So this way we know the change, and then new position or the character position which we are looking for is m character pos 0, and then we want to plus x position change, and then for the y we want to add the y pos change, and then we have the character position, which we should be good. And let's confirm that it should work like that. So then if we have the a character position is not none, so we found the a. Let's increment the counter again. So now we should have less than 73 candidates. Okay, we have 0. It indicates that we have some issue. Okay, yes. Character position. Let's actually check the character position. So as we remember, we had the one example value or starting point in the location 4. So let's print the character position. Okay, 9 and 1. Okay, now I think we have some. If we want to, okay, we need to swap these around. That's completely fine. So then this logic will work. I think it should be. So now it should say 1. Okay. Let's check one with so if we give it a previous, will it still give us the yes, it did. Wonderful. So let's just clear that out, run it. Okay, let's get that. So we have 36. Okay, looks good. And what we can basically do is copy paste this code again, and then check for the last character of S. And now we can utilize this mchar pos. So as we know, we are this far, we can be sure that all the kind of preconditions are met, and we are only interested into the change, what happened here. Then we can just add the changes to the A char position, and then let's find the S character positions, and then if S char position is not none, so we found something. Let's increment the counter. We have 21. How many times does Xmas appear? I would say 21 times. That's not right answer. If you're stuck, make sure you're using full input data. Aha. Yes. Okay, so actually this is an interesting case. Currently we take only one M character position from it, but we actually need to collect a list. So if actually we can do it easily. Just results. So empty list. Then we are not returning here. We are just result append position. Yes. And then in the end, we can just return results. It's difficult word to write. And then here we can just check the length. So basically len mchar positions is not 0. And actually, yes. And in here, let's do it like this. So A char pos is the A char pos one, or the first item from the list. And same, or actually that is the only kind of edge case. Otherwise, we need to loop these mchar poses true. Because those could be around and you can have multiple ones. But now if we just make it like this and run it. Mchar. Oh, I didn't run this, didn't I? And then like that. Okay, 40. It's already quite much higher. That's not the right answer. Okay, interesting. So now we need to think a bit. It could be that there is some edge cases that I'm missing. So what happens basically if if let's say if y is 0 and then or could we just simplify this since this edge case is kind of making it potentially difficult to so if we would have just these positions and then if so if we have these positions and then I guess it will error out. But if we do it just or we can actually, yeah, let's try. Because I have a feeling that it should, yes. String in, yes, it's correct. So if we just wrap it in try, this is not the cleanest one, but for this use. Okay, now we got quite a much higher number. Started to wonder that could it be a correct one? Too high. Ah. Okay, that makes sense. What I'm not seeing here. X. Yeah, so we have all the X's. And then we have find all the M characters. So if we would do so that the manipulated input would be array of M character and then we would duplicate this and then just have X in the middle. What would it say? 0. Yeah, of course it would be 0. But mcharpos would be. Why it would be? Okay. Xchar locations, that I need to override as well. So in this case, it would be double of it's 1 and then 1, I think. Eight items. Okay. So if I just make this test set and then it will be like xmas and then let's add one more. Oops. Yes. Then xmas, then xmas. Oops. And then let's run it. Xmas. For how? How? Like what? What? So then it will go here. Oh. Let's do it like this so we can. It is located like how? So if I then check this. What if we remove this one? I'm like wondering, is it now causing this issue that no, but no side effects. mm, One minus one x1 like how? Oh. Yeah. Now I know. If one below zero or so basically this is so basically what happens when the index goes minus, so below zero, in Python it's not index out of bound error, but instead it's switching or accessing the last element of the array. So basically what we need to do, we need to skip those. Yeah. And so if we just are below, then let's continue. Okay, then this should now. Yes. Okay. So if we now just comment these out, and we run this, we need to then run the manipulate. Where was it there? Yes, and then Oh, yeah, I forgot to print. Print, it will take some time. And previously I can't recall what we submitted, but I feel that it was way more than let's actually remove the prints for now and do the calculation again. Yeah. Yes, finally. Okay. Yeah, that was a tricky thing, a trickier thing that I expected. This was. I knew that that you can use negative index to or -1 index to x. X is the last element without any errors, but this was good reminder that this edge case may surprise still, even though you know how the language behaves. I think it is good time now to pause this video. It has been very long already, or getting very long already. So we managed to get the day four part one done, and let's continue with the part 2 in the next video. Big thanks if you managed to watch this far, and see you in the next video. See ya.